Okay, so today's lesson
Max.
is evaluating expressions. Okay, so in today's lesson we're going to be evaluating expressions. We're going to define what variable and algebraic expression are. We're going to talk about showing multiplication and division in different ways. And the big thing, number 3, is substituting for variables to evaluate expressions. And you'll learn what that means in just a second. Okay, a variable is a symbol, and it's usually a letter that represents one or more numbers. And I say usually a letter because sometimes we use symbols that are actually Greek letters, and so they don't look like letters that we would be familiar with. And you all are familiar probably with the pi symbol. That's, well, actually pi stands for a number, so that's not a variable. But sometimes we'll use things like this, not in this class, but sometimes you'll see things like that in other classes as you go on down the road. So we want to define this correctly. It's a symbol, usually a letter. It represents one or more numbers. Question?
Is the third line, is that numbers? Because you kind of connected your
Yeah, it's an N. Sometimes my pen has a mind of its own. There we go. Okay, next one. An algebraic expression and we have ghostwriting going on today, which is appropriate because it's Halloween. An algebraic expression, to carry that up there a little bit, is a mathematical phrase with at least one variable. And below are some examples of algebraic expressions. They're just expressions that use letters and numbers or just letters. So A plus B is an algebraic expression. T plus 5 is an algebraic expression. Here we have some order of operations symbols going on. We've got 6 minus b in parentheses divided by c. Those are all types of algebraic expressions that we may be working with. Okay, the next thing we want to talk about briefly is just how we show multiplication and division in different ways. We already talked about this a little bit in our order of operations lessons. If we want to multiply a times b, we can show this in many different ways. So the first way, we can say a times b with a just an X sign to represent times. In algebra, we almost never do it this way. Can anyone think of a reason why that might be confusing in algebra? Caitlin?
Because that could represent a letter.
It could, yeah, the X could be the variable X. So just to eliminate any confusion, we almost never do this. There are a number of other ways we could show multiplication. Does anyone have any ideas of how we could show multiplication? Caleb?
Can you use parentheses?
We could. So we could do parentheses A, parentheses B. That would mean A times B. Johnny?
Do the dot.
We could do the dot. A times B. And I wish I hadn't I put that bullet there, but that dot kind of looks like a multiplication dot. I'm just going to scratch that out. Any other ways that you can think of to show multiplication? Ben?
Like A and B, like smushed together.
Smushed together, all right, just A, B. I was hoping someone would come up with this one. A, B is the preferred way to show multiplication in algebra. That means A times B. Sometimes in an expression, I'll see people think that this, if A represents, or 5 is, let me say that again. If A represents 5 and B represents 3, this would be 5 times 3, which is 15. It's not 53. You can't put the 5 in and then the 3. It doesn't just mean 2 digits. It means A times B. Just a couple other ways. You could also put just one of the numbers in parentheses, and that would also show multiplication. Okay, but there's a special one down here. We'll work with these types of expressions a lot. A times parentheses B plus C is telling us that we need to add B and C first and then multiplied by a. Just use our order of operations that we already learned about. When we write a constant, and a constant is a number, times a variable, it is usually written with no sign. So an example is if we write 2a, this means 2 times a. We always write it with the number first, so it would not be correct to write a2. You have to actually say 2a. Another example, maybe 5x means 5 times x. These are the ways that we are most commonly going to see. Okay, any questions about that?
Wait.
Need another second? We good? Okay. Division is only shown 2 ways in equations. To show a divided by b, the only 2 ways we could really write this are a, division sign, b, or a over b. A fraction bar means division. This is the way we're going to use in algebra. So when you see a over b, you don't automatically need to think fraction. You can also think this is just a divided by b. Okay, objective 3, this is the most important part of our lesson. We formed the foundation. This is what you're actually going to do. We're going to substitute for variables to evaluate expressions. So the directions tell us evaluate each expression. The word evaluate just basically means to solve. So we're going to find what each expression actually equals. There's no equal sign there, but we're going to figure out if we substitute in some numbers what the answer would be. We're going to use the values p equals 2, n equals 3, and s equals 5. So if we look at our first example, we have 2p plus 7. Remember that 2 and p, if they're written right next to each other, means 2 times p. We're going to go back up here where it tells us that p equals 2. So instead of the letter p, we're going to put a 2. We're going to substitute that in. So we have 2 times 2. And I do have to use a little dot or a parenthesis, because if I just wrote those 2's right next to each other, it would say 22. And that's not what we want. We have 2 times 2 plus 7. Is everyone okay with what I just did? Taking the 2 from here, I put that in my expression instead of p. Now I use order of operations to solve. 2 times 2 is 4, plus 7, and 4 plus 7 is 11. So I have just evaluated that expression for p equals 2 and found that it equals 11. Okay, next example has all 3 variables. We have p plus n times s, and there's a little dot in there. It wouldn't need to be there. I could also have just written ns. Ben?
With with that problem, what is the other problem? Could it be like a negative p or a negative n or negative s?
It is possible, yes. Sometimes it will tell us that p equals a negative number. So yes, that's possible. Most of what you have to do will be positive, but we will do some examples with negatives. Okay, so I'm going to take each number from up top and I'm going to put it into this expression. P equals 2, so I have 2 plus parenthesis, n equals 3. So in place of n, I'm going to put a 3. S is 5, so in place of s, I'm going to put a 5. Now I'm going to do order of operations. I'm going to do what's in the parentheses first. So I have 2 plus 3 times 5 is 15, and 2 plus 15 is 17. Okay, any questions? Okay, the next slide has an example for you to try, so I'm going to pause our video and you can give that one a shot. Okay, so we're using these values, putting them into this expression. I have n, which is 3, plus t, which is 5, times s. Wait a second, I have a mistake off of mine. Yours was correct, wasn't it? Did yours say s here? Yeah. Okay, so I fixed it on yours, forgot to fix it on mine. Okay, so times 7. Some of you did 3 times 5 instead of 3 plus 5 here, so that was one common mistake I saw. 3 plus 5 is 8, and then we need to do 8 times 7. The other common mistake is some of you, instead of putting the dot for multiplication, changed that to addition, and then you did 8 plus 7, but it's 8 times 7 which is 56. So just be careful, make sure you're doing the right operations, but all of you that I saw did the right type of substitution. Okay, we are now going to look at some examples with negative numbers. Negative numbers you just have to be more careful with because we have more signs to deal with. So we have 2h plus 5x plus 3. H equals 4, x equals negative 6. So we have 2 times 4 plus 5 times negative 6 plus 3. I tend to use parentheses more than the dots when I do multiplication, especially when negative numbers are involved. It's just easier to keep track of that negative sign, I feel, if it's inside the parentheses. Okay, there's nothing to do inside of the parentheses. It's already down to one number. The parentheses in this case are just telling us to multiply. There's no exponents.
Interruption. Aiden Waldron, please report to the office. Aiden Waldron, please report to the office.
Okay, so I'm going to just do my multiplication first. 2 times 4 is 8, plus 5 times negative 6 is negative 30. And I'm going to keep my parentheses just because it looks less confusing to me with the signs. And then I have plus 3. Now I'm going to add and subtract from left to right. 8 plus negative 30, let's do one step at a time, is going to be negative 22. I have different signs, so I subtract and keep the sign of the larger number, plus 3. Again, I have different signs, so I'm going to subtract. 22 minus 3 is 19, and I'm going to keep the sign of the larger number. So when you're dealing with negatives, this is where if you were a little bit weak on your addition and subtraction rules, you might have a little bit of trouble with this because there are so many cases where we have to apply the rules. It's easy to get mixed up on one. It is written up on the board under the flag. I do have the rules up there, so if you forget, you can take a glance up there. Ben, question?
How'd you get 4?
Because H equals 4.
Oh, I
So I
didn't
put
see
the
that.
4.
I didn't see that.
Mackenzie?
I got negative 41.
Did you? You're just supposed to follow along as I do it, so you shouldn't have gotten something different. Make sure you copy down what I have, and when we do the you try, those ones you should do on your own. Try not to work ahead too much on these because I want you to make sure you're following what I'm doing. Okay, next example, we have 5 plus negative 16 over f. What does this fraction bar tell us to do?
Divide.
Divide. Plus 2n, this is multiplication. So I have 5 plus, wait, let me fix that 5 because it's a little messy. There we go, 5 plus negative 16 over f, which is negative 4, plus 2 times n, and n is negative 9. Sammy?
I have a question.
Yes.
Would this be on a homework, like the word telling us what f equals?
Yes. Yeah, you have to be told what the variables equal, otherwise you can't evaluate an expression. Okay, good question. So I'm going to multiply and divide first. So I'm going to do this division. I'm going to do this multiplication first. Negative 16 divided by negative 4 is positive 4. 2 times negative 9 is negative 18. Now I'm going to add and subtract from left to right, and I'm just going to do one set of numbers at a time. So 5 plus 4 is 9, plus negative 18. My signs are different. I'm going to subtract and keep the sign of the larger number. 18 minus 9 is 9. 18 is the number with the larger absolute value, so my answer is going to be negative. So I have negative 9. Okay, the next two are two for you to try using negative numbers, so give those a try. I'm going to pause the video. Okay, so you guys are having a little bit of trouble sticking the negative signs in, and there's a few things that are difficult for you. So I want you to make sure first that you recopy the problem with the number. Some of you skip that step, and it makes it hard for me to see where you're going with your work, and also I think hard for you to follow. So the first thing I'm going to do is rewrite the problem with these numbers inside. So 5 times x is 5 times negative 5 minus. Some of you neglected to bring down your operation sign, so you didn't put a minus sign here, and then you ended up multiplying everything together and got really big numbers. Minus 6 times f, and f is negative 6. Put a line in there. Okay? and then minus 7. So everybody's first step should look like this, except you may have used dots instead of parentheses to show multiplication. This is kind of a required first step. Okay, now I'm going to go through, I'm going to do my multiplication and division from left to right. 5 times negative 5 is negative 25. I need to bring down this minus sign. Some of you forgot that. 6 times negative 6 is negative 36. And then I'll bring down my minus 7. Okay, so pretty much everybody should also have this as your second step. If this is not what you have, I would copy down what I'm doing so that you have it as a reference. Now, minus and negative actually means what? Positive. We need to add. So this really means, I'm going to rewrite this step, negative 25 plus 36 minus 7. Okay, so I'm going to start with the negative 25 plus 36. Different signs, subtract, and it's going to be positive because my larger number is positive. 65 minus 25 is 11. So I have 11 minus 7, which is 4. Okay, any questions about what I did? Okay, let's take a look at the next one. The next one had a really confusing part in it. It had a negative sign in front of the whole fraction. And some of you, in fact, most of you, as I looked around, dropped that negative sign and did not include that. Jonathan?
Positive 36 after negative.
Minus a negative is positive. Remember that rule.
Wait, you said I got it right. I didn't
Yeah,
bring
you did.
that. I didn't bring that exit.
Well, you sometimes do mistakes, end up making it right. So even though you made a mistake, you're okay. All right, so I'm going to bring down my negative sign, and then I'm going to do negative 20 over n. N is negative 5 plus 9 plus 8 times 5. Everyone should have this as your first step. Everyone's first step should be identical. There may be future steps where maybe you do 2 multiplications in one, somebody else only does 1, but the first step should always look alike. I'm going to do my multiplication and division first. Negative 20 divided by negative 5. If I divide the same sign, the answer is positive. So I have positive 4. However, I have this negative sign in front of the whole fraction, so it's actually a negative 4. That one is very tricky. I'm not worried if you missed that, because that's a complicated one. Plus 9 plus 8 times 5 is 40. Negative 4 plus 9 is 5. Plus 40 does work out to be 45. And some people did have the right answer there. More commonly, people had, let's see, 53 because you didn't make that 4 negative. Johnny, question?
Well, I accidentally made 4 negative. I forgot to change the
Okay,
double
so
negative to a positive.
what Johnny did is he did negative 20 divided by negative 5 and made it negative. Anyhow, he forgot about this negative, but he still got it right. So occasionally it does work out that 2
I thought-
mistakes do make a correct
The
answer.
negative sign was like an accident.
Yeah, no, it wasn't an accident. Okay, any questions about this before you try one more set?
Nope.
Ben?
First, like the 20 somewhere was 5 negative, and there's like a negative sign off to the side.
Then it would be positive. Okay. I have an exit ticket for you to do. I want you to copy the problem, then show me as your first step how you're going to substitute the numbers in. I will come around to check your exit ticket. We only have, actually, you know what? This took more time than anticipated. Let's not come around and check the exit ticket right now. Let's not worry about this. I'm going to pass out the worksheet to you.
Wait, so
And
no, the exit ticket?
yeah, don't do it.